You might see questions in the linear algebra section that have absolute value involved. So let's review what absolute value means. Absolute value is actually just a measure of the distance of a number from 0 if you're thinking about it on a number line. So why this matters is, so let's say we have 2 points. We've got 3 and -3. So what's the distance from 0 to 3? Well, the distance from 0 to 3 is just 3 units. And notice we don't really care about the sign here. We just care about the raw distance. We don't, the magnitude. We don't actually care if it's like -3 distance doesn't really make sense. It's just 3 units away. Notice with -3, what's the distance from -3 to 0? It's also just 3. Because again, we don't care about the fact that this is negative. We just want to know, okay, it's going to be 1, 2, well, try that again. 1, 2, 3 units away. And that's all we care about. The sign doesn't matter. So absolute value is a measure of distance, often from 0. And the symbol we use for it are these little bars. So when you have a negative number in between these absolute value bars, you can evaluate that as just being 5, because this is asking what is the distance of -5 from the point 0, from the origin, and the answer is 5. It's just 5 units away. So you basically drop that negative sign and just make it positive. If you have a positive number in absolute value bars, it just stays positive because 6 is 6 units away from 0. No problem. One thing to be careful about, though, when you have anything other than an integer or anything other than a number, if you have a binomial, if you have a variable, like if you had, we'll talk about in a second, absolute value of -x, this doesn't apply as easily. So this does not equal, use red here, this does not equal x plus 2. You can't like distribute the absolute value. It doesn't work like that. Same thing, this would not equal just x. Doesn't work like that. You can only apply the trick, making it net positive, when it's just a number in these bars. So where does this play out? What kind of questions might you see on absolute value on the SAT? So you might see something like this. If the absolute value of 2x minus 4 equals 28, what is the smallest possible value of x? Notice you don't want to just say, oh, okay, well, 2x plus 4 equals 28, because that does not work. You cannot do that, as we just said. So what do you have to do? Well, think about it. If this ends up equaling, when we plug in an x, if this ends up equaling 28, then the absolute value of 28 is 28, and they would be equal. So if we find an x that would make this equal 28, we'd be good to go. But also remember, if this ends up when we plug in an x equaling -28, then the absolute value bars will make it positive, and then 28 will equal 28. So we can also set this equal to -28, and that's your trick for solving these absolute value equations. Take your equation, set it equal to the positive of the number on the right, and set it equal to the negative of the number on the right, and then solve them. So here we're going to get 2x is equal to 32, or x is equal to 16. Here we're going to get 2x equals -24, or x equals -12. And notice, if you wanted to, you could test these. You could plug these in to your equation, and you would see both of them would give you something that would end up equaling 28. Now, they want in this question the smallest possible value of x, so we would choose -12 as the answer, even though 16 would also be a solution. Now, what about this? For what value of n does 2n plus 3 plus 2 equal 0? And the trick here is to do a little bit of a quick rearrangement, right? We want to get it to this form so that we can apply our little trick. And right now we have our number on the left side with the absolute value. So let's move that to the right. Let's subtract 2 from both sides. And we're going to get the absolute value of 2n plus 3 equals -2. Now, before you go on and try our little trick here, notice that we have kind of an issue. When will this ever equal something negative? Never, right? This is always going to be positive. No matter what n goes in here, the absolute value will turn that number positive. So this can never equal a negative number. So the answer is no solutions. Empty set. There are no n's that will make this work, right? And if you wanted to, just test some stuff out. You'll see you'll never get something that will equal -2. You will never get a negative quantity here that will add to 2 to make it equal to 0. It just won't happen. So that's how you tackle absolute value equations.